And what we've shown here is how you can create a 3D model. So in terms of what we are trying to do with this video, our ABAQUS CAE objective really is to design the 3D parts that is representative of this. And that will include the heatsink base, the circular fins, the inlet and outlet pipes, and the curved return channel. So these are the three components that we have, and we're now going to go into ABAQUS so that I can illustrate how you do all of that. Rename this model. I'm going to call it my heatsink. So heatsink model, and we can then start running through this. I would normally either click on this, but let's use this. So I'll click on this create part, and then the first thing we're going to have is a HIC. So we can call that a heatsink base. And if you look at what you're trying to do here, so we've got a modeling space that is 3D, which is what we need. There are still the same things we talked about in the previous video about how the virtual domain type you're trying to model. Is it deformable? Is it discrete, rigid? Is it analytical? Is it Eulerian? And in this case, I will allow it to be deformable, but because it's really a temperature study, it sort of doesn't matter so much, except you're doing a coupled thermal, and displacement-based modeling, in which case you will allow some deformation. But really, what we're tracking in this study is the temperature profile, but we're not going to get that far at the moment. So I'll leave it as deformable just to give us freedom to be able to create, to use it in a coupled thermal analysis later on. And so the base feature that we have in mind are this. So we want to create a solid structure, a solid system, which is really the 3D parts we're looking at here. And these are the three methods we talked about: extrusion, revolution, and sweeping. So this first case, we want to use the extrusion method. By all means, you could also do a shell system or a wire and point, but this tends to be more for the 2D domain that we talked about earlier on, because a shell is really a 2D geometry, wire and point are 2D. So we've spoken about this in a previous video. Again, I do encourage you to have a look at that video if you want. But for this 3D system, we're going to restrict ourselves to solid. So I'm going to click on this solid. I'll leave this approximate size the way it is, because again, the geometry that we're looking at is something as wide as 60. So it will be fine. And then we'll click continue. So since I want to create first this heatsink base, so what I need is to create the 2D geometry of the area of interest, which is a rectangle. So I'll click on this. So I always want to work with the coordinates. So this will be -30 and 15 on the top axis, and then what happens on the other axis will be 30 and -15. So this gives me the geometry of interest that I'm working with, and this is fine. So I'm just clicking done. And then how deep do you want this to be? Okay, 20 is fine. So remember what we said before. So this is our geometry of interest. So if I open up the heatsink base and look at the features that we're looking at, so you could see the solid extrusion. This tells you the L. So remember, in the mathematics, this is the L. So we can change this number if we want. And this is why I said it's a variable that you could always change if you want. You could also click here and do some editing of the geometry. If you think this is not what you think, you can also do an editing of that geometry. But we are happy with what we have, and we leave it like that. So but then in this geometry of interest, what we notice here is that this is a system that is extruded, and it's got this depth to it. And this depth we need to extrude and do extrusion so that we can create that depth. So how do we do that? So if we come back here, there are a lot of features that we can use within this place to do that. So if you look at this one, this is called the create cut extrude. So create cut. So we want to push in, not pull out. So if you look at the arrow here, it says you're pushing in. So to create a cut, this one you start with the base and you're pulling out. So they are all both extrusion features. But we're going to just click on that and it says here, select a plane for the extrude cut. So this is the plane, and select the vertical axis. I want this to be my vertical axis, so I have a plane that is correct. So I need to now sketch the geometry that I want to again use to extrude cut through the system. So it will still be a rectangle geometry. So I'll use -27.5 and 12.5 as the point of interest. So I'll have 2.5 this way and 2.5 that way. And then on this other end, I've got 27.5 and -12.5. So we've got the geometry sketch that we want. And now remember, what we're trying to do here is to reverse the process like what we did before. So, and again, it does tell you here, if you look what it's saying, okay, this is the geometry that we want to use the extrusion method, but we want to push it deep into the system. So I'm going to pull it all the way inward. There are some end conditions we have here. Either you pull all inward so that it cuts through the system, which is not what we want. Rather, we want it to go up to we don't have a face in mind. So if we have another face, maybe we can extrude up to that face. Really want to get to a blind point. So the depth of this system is 20. We still want it to have a thickness of 2.5. So I'm going to make that as 17.5 so that you got a 2.5 thickness at the base, and that gives you the geometry of interest. So you could see right away we've used a reverse extrusion, while in the other case we extruded upwards to create the length. Now we extruded through the cut to create this depth, and we have everything that we need here. So if we look at here again, I could see that there are some interesting things, and these are the channels. So the gaps in the channels that exist here, all of them are about 2.5 millimeter in radius. So we are going to work with all of them in this sketch. So what do we need to do? So again, I'm going to have to extrude cut through the system. So I'll start with this system here and clear the fat. Okay, so this is fine, and then we just want to put that extrusion cut somewhere here. So I'll click on there, click here, and then the point I want is minus 23.5 and a 0 point. So this is the point of interest, and we could just use a mirror function to push it onto the other side. So again, I click on this button and use the mirror function. I say I want you to create a copy. This is the mirror line I want to use, and this is the geometry I want to use, and it can create that. So we know that this is 2.5 in radius. We could also check how big that is. So 2.5 in radius. So this is fine. So we click done. Now it says, okay, you're extruding, cutting, and this is fine. However, if you extrude cut through the whole material, then it will also make a hole at the back, and we know that there is no hole at the back here. So what we are going to do is to again do up to a blind. I know that this system is 2.5 in thickness, so I could say just do a blind of something a little bit thicker than that, maybe just 3. So, and that's fine. So that creates the hole on that window, which is fine. Now we do the same thing, because here we can see there's a hole there and there's another hole here. So we can do again the same extrude cut. I'll select this window, select this as my vertical line. It's still the same diameter, so I'll click here and then maybe minus 2.5 and 0, and that's fine. So we've got that, and then click done. So you can see now it shows us here, but we want it to extrude cut through the whole medium, even onto the back end. It's because we've got those channels completely on this side. So unlike the other cases where we have a blind, this can be through all, and click OK. So in one flow, it creates this and creates that, and we have the whole base of the structure of interest. So this is the heatsink base, and this is fantastic, and we're happy with the way this looks. The next thing we need to think about still here is this heatsinks. So this heatsink pin, these circular fins are all correctly positioned. You know, they are circular fins. You could see that they have a staggered arrangement somehow with them, so we can go ahead and work with this. But the thing is that it's coming up from the system up, so we are going to, it's made from the same material. It's one integral system that is created as one solid block. So what do we do? So we come back here. Then the next thing, while still working on this system, is to introduce this feature. But here we're going to use the extrude solid. So now we're going to pull up to create the system. So I'm going to click here, and then it says select the plane. So I'm going to select that base plane, and this is my vertical axis. So fantastic. So everything looks okay here. Now what I will do is I'll give myself some guidelines. So this is a center line, and then maybe 1, 2, 3. So somewhere around here will be what we have. 1, 2, 3. So 1, 2, 3. So we've got that line, and then maybe somewhere probably in the middle here you also have that, and maybe in the middle here you also have that. If you are designing, you have an accurate representation of this. So if you look at the Ambrine paper, so they had a clear dimensions of how everything is fitted and how it fits across the whole system, and it runs from one end to another. We can use all of that, but I'm trying to concentrate everything in the middle, just, you know, for ease of representation. You know, it doesn't matter. I mean, we can do this and have that, but we're going to concentrate everything in the middle here for our sake. So once we have that, then I'm going to create one of the heat sinks. So it's probably something here, just of a certain diameter. Doesn't really matter. And then I'm going to use a pattern, you know, a pattern and linear pattern. So I'll select that, and then click done. So it comes up with this window that tells me, okay, this directions is quite a lot. So if I put 4 there, and then I put maybe 4 here, so I want this flipped down, so I flip it. I probably for now just concentrate on the first 2, and then we could go downwards so that we have the first. Okay, so this is fine, and maybe that distance a bit too small because we want to cover everything. So let's do 4.4. Okay, so if we do 4.25, so we've got 4.25 on both sides. So we've got the right arrangement. But what we know is that this actually staggered in the representation that we had in mind. So what do we do with this? So what I'm going to do is I'm going to introduce a line here, and then I'm going to translate this in a staggered manner, this second assembly. So what I'm going to do is I'm going to use this option that says move. So I'll press and hold and select move. So I'm going to move, and what entities do I want to move? So I'll simply select these three entities, making sure that I'm not moving the line because the line is our guideline. And then I will now zoom in a bit closer into the space and click done. So I want to move it from here to somewhere in the middle here. Again, you need to be very accurate and find the exact dimension, but I'm just trying to show what you're doing. So you move that in the middle to see that you've got that staggered arrangement, and then we delete this. So this is beautiful, this is fine. And then we can just simply, create more linear patterns of this base geometry. So what we're going to do is go into linear pattern, and we'll select that base geometry again, and then we click OK. So again, I want that to be now doubled to be 8.5, and you don't need any patterning on this axis. So this is basically a 1, and then we can move further, and it looks like everything is correct the way we wanted. So I'll click OK. So we've started from where we are to where we want. There's this extra region that we don't want, so I can go ahead and delete that and click done. So we've got a staggered arrangement. Again, if you are interested in replicating it to fill up the whole space as the paper stated, you can do that. But since I already started with this sort of a simpler model, we're going to stick with the model we set out for ourselves at the beginning. But the paper actually had this filling the whole space in the middle. So this is what we have here. And what I could do, because I've got a sketch and I may have to reuse the sketch, so why not save that sketch? So I could say the fin arrangement. So it then becomes saved, enter, so that if I want to use it, I can call it up any other time. Maybe if I want to use it in a different modeling. So it's always once you've created a complex geometry to sort of save it, and then because you can then call up on that later on. So I'll right click and click done. So you can see it looks okay the way it's supposed to be, and this is fine. So we can move this all upwards. So again, if we study, you find that this didn't really reach all the way to the top. I think it's probably somewhere just a little bit below the top of that. So, or we could go all the way up if we want. So let's go all the way up to the height that we want. So we want it to go to 17.5. So it starts from that base to 17.5 upwards. The direction is right here, and we click OK. So you can see now it looks perfect. So we've got our geometries, everything looks all right, and it looks to filling up that space. So this becomes our base geometry, and we are happy with this first part. So this heat sink base with the fins are all stated here, and we've used the extrusion method to create this. So the next thing is this inlet and outlet pipes, and you can see that they're exactly the same. So why not, let's create that. So we're going to create this, and so this will be the inlet outlet pipe. Okay, so we've got that. We are now going to use a revolution method, which is the second method to illustrate this. So what do we do? So again, remember, we have already the center line, the x-axis defined for us. This is the zero line. So what we want to now do is to create the 2D geometry that will create this pipe. And for it to be a 2D geometry, we need to start with a rectangle geometry. So the first thing we need to do here is I'll start off somewhere around there. This pipe is of length 20, so it's of length 20. So on the downside here, I'm going to have minus. So you start from the inner radius is 2.5, so 2.5 and minus 10. Okay, so this is where this part. So this is the first line, and we know I want it to be 3 millimeter in radius. So from 2.5, I'll go backwards to 3 and minus 10. Okay, so we've got that region, and then we just simply need to do the thing on the offside. We've got 3 still on the x-axis and 10 and then we'll go inwards again, so we get 2.510, and then finally we end up here. So this becomes the geometry that we have in mind. So these are two geometry. We can dimension that and see how thick it is. So we want it to be as thick as 0.5, and then we want it to be as high as 20. So this is the 2D geometry on this YZ axis, which we in terms of our polar coordinates is an RZ axis, and we're happy with what we have here. So then we'll now cancel and then click done. So now it tells us how much revolution do you want to revolve this. This is the angle theta. So I want it to revolve all the way around and close up on itself. I don't want any gap because it's a pipe. So I'll do 360 degrees. So that way you have a simple way of creating this. Of course, you can create it with another method, but I wanted to use this method to illustrate this revolution approach. In this case, it's a really simple geometry. You could have done extrusion method, but for the purposes of this video, we are going to use this. So I'm happy with that. And again, if you notice that the inlet and outlet pipe are exactly the same, so that's fine. We are going to then do an assembly later on. So the final part is the coolant channel. So the coolant channel we're going to create using a sweeping method. Okay, so what is interesting with the coolant channel is that you've got a radius here, so you've got something, and then you've got a line that lines from here to there. So this total length is 60, so half of it is 30. So we've got a radius of some kind. So what do? We need to specify a path. So I'll start off first using this option. So this is the center, and I'll probably start with maybe -10. So -10 to 10. So this is fine. Again, anywhere you like on this plane, you can sketch the path. It doesn't really matter what this path is defined. So this is one part of the path. And then I could then go back and start from here. I want to go, so this is 0. So I want to go to -30 and 10. So this is one part of the system. Okay. And then I will probably want to use the mirror algorithm. So I'll click on this, and then I'll click and hold and select this. So I want to create a copy. This is a mirror line, and the entities I want to use is this entity, and click done. So we've got now a path that represents what we are looking for, effectively how it should be. So we click done. So now it said the sweep path has been created perfectly the way we want. This is the sweep direction, so it's going to start. Remember the T axis that we talked about, so it starts tracking this in always a tangential manner, and always going until you come back to this end. So the space we want is there. Now we want to create the geometry of interest that we want to use for this. So again, it's a circular geometry with an internal diameter of 2.5. So we got -2.5 and 0. But we also want it to be thick by 0.5. So again, I'll click there again, and then I want this to be 3 and 0. So because it's the same thickness as the inlet and outlet pipeline. So this will be the geometry. So we've got the inside and outside one to make it into a hollow system, and then we can. So this will now be what, so this base will be what you're going to extrude, and I click done. So you can see it's created the extrusion, and we are happy with how it's tracked the whole path. And we've got the geometry of interest. So again, if you wanted a different kind of thing, you could also do that as well. If you didn't want to have this bifurcation in the middle, I could have just done one long line to get to that end, but I wanted to use the mirror function, so this is why I did this. So, but it doesn't really matter, because when you start meshing, all this will go away. So we've got all the three parts. So the coolant channel, the heatsink base, and the inlet and outlet pipe. So the final thing we need to do is to bring all of this all together. So what do? So we go to the assembly module. So if I switch to the assembly, now I could use this to bring the instances. So I'll bring all three instances together. Okay, so, or maybe let's just do them one by one. So I pick on this and pick on that. Okay, and then click OK. So now what I have here are the two inlet pipes. So this already is here, oriented differently, but it's positioned wrong. So we need to bring it to this point, to that point. And so we're going to translate it using basically making sure that this point, the center line of this, connects with the center of that. So I'm going to use this button, which is a translate button. This is what I want. So what I need to is to zoom in into here. So where the center of this geometry, which is probably around here. So again, if you're really struggling with this, so you may go into the assembly module for now and open up this and just tell it to, for now, you suppress this so that you have clearly what you want. So, and then you now click that center point, okay? And then you can resume this, and then you go to where you want it to connect. So we want it to be connected to this point, so which is the center of this. So, and you could see now it looks perfect. It looks as we expect it to be, and we're happy with this. So this is one of the inlet pipe, perfectly arranged the way it should be, sitting in that space, filling that gap so that you could see the whole. It's not everything is arranged, because there was a bit of thought in how we created this geometry initially. So the next thing we're going to do is to create a duplicate of this particular inlet pipe, and we're going to use the patterning option. So if you click on the patterning, you select what you want, it comes up with this option. So we're going to relieve this and then reduce this, so we only want one, and then we'll put this something like 10 or maybe, okay, so let's just look at 20. Okay, so like we did before, we are going to suppress this bit. So if I suppress that, so when we suppress that, then we'll translate. So I'm going to translate this, select the center point here, and then I'm going to resume this bit and then find the center point where I want to coincide it with, which will be the middle of that point. And then I pick that point, and then that gives me this region. So I can then look at maybe part instances to show how it's looking in reality. So I've got the two inlet pipes and everything. So the next thing I need to now include here is the next instance. So I'll double click on here, then I'll bring the coolant channel. Okay, so the coolant channel looks exactly like what it should be, however it's not positioned well. So what we're going to do is that we're going to do what we did before. So I'm going to take this point and translate it to that point. So I'll select that, select the coolant channel, and then I want it to select from the center point here, and then go all the way, then I rotate, go all the way to the other end, and then select that point there. So, and once you get it into position, it looks correct the way it's supposed to do, then okay. And what we've shown here is how you can create a 3D model. One thing that is missing in this video is the fluids that are flowing through the system, because for us to model this, we need to also capture the fluids. So in the next video, I'll show you how to use an Eulerian approach to model that fluid. So if you're interested in that video, check the next video. So if you haven't subscribed to this channel, I do encourage you to please subscribe, so when contents like this are made, you'll be the first to see it. And catch you in the next. Bye bye.